this example, we are writing an equation for the function graph. So we have this kind of crazy looking graph, and they want us to write a function. Well, how's it going to work? In general, how it works, if you come down here to, here's the notes. This is the exam 3 notes. And you can see I'm going through an example here, and I'm showing that basically when it comes down to it, here's the x-intercepts are going to be on the top and the vertical asymptotes are going to be on the bottom. Okay, let's start with that idea. So in general, it's going to be y equals some kind of number, call it k, and then on the top we're going to have x-intercepts, x minus x-intercept. On the bottom, we're going to have x minus VA, vertical asymptote, and x minus VA, vertical asymptote. Now I'm doing 2 vertical asymptotes because we have 2. One of them's right here. There's a vertical asymptote at -3. The other one's right here at 4. So 2 vertical asymptotes and 1 x-intercept right there is our x-intercept at 2. So we have 1 x-intercept, 2 vertical asymptotes. So the x-intercepts go in the numerator, the vertical asymptotes in the denominator. That's what I'm showing right here in the exam 3 notes. Intercepts in the top, vertical asymptotes in the bottom, and the constant in the front. Now I want to talk about the powers. I see how some of them have second powers, some of them don't. How do you know? Well, here's the story. When a graph bounces at an x-intercept, let me make this a little bigger for you. See right here at 2, how it bounces? That's a second power. If it only passes through, it's just first power. So let's look at our x-intercept. Our x-intercept, it just passes through. It only passes through. It does not bounce, right? It doesn't go boing and bounce back down. If it bounces back down, that would be second power. But it doesn't bounce down. It only passes through. So it's just first power. You don't have to write the 1. It's understood to be there. I'm just trying to be extra clear. Now, how about the vertical asymptotes? Well, the vertical asymptotes, oh, you know what, I should fill in the numbers. What is the x-intercept? It's 2. And what are the vertical asymptotes? -3 and 4. Right, there we go. Anyway, let's do the power now for the vertical asymptotes. So special note number 2. At a vertical asymptote, if a graph goes up on both sides of it or down on both sides of it, it is second power at that vertical asymptote. At a normal vertical asymptote points, the graph goes up on one side, down on the other, and those are first power. So if it goes up on one side, down on the other, like that guy, that'll be first power. And if it goes down on both, or if it went up on both, for that vertical asymptote, that'll be second power. Does that make sense? It's kind of like bouncing. It looks like a bounce, right? Because if you bounce, you're down on both or up on both. That's kind of what and that's always second power. Bouncing for x-intercepts is second power. Well, it's kind of the same thing for the vertical asymptotes. If it bounces, so to speak, they both go down or they both go up, that's second power. Whereas if at a dotted line, if one side is up and one side is down, that's just first power. But if at a dotted line, both sides are down or both sides are up, that's second. Why is that second power? Well, because if you think about x squared, what's the graph of x squared? It's a U-shape, right? And negative x squared is a U-shape down. It's the same on both sides. That's because if you plug in like positive, let's say 3, or negative 3, either way you get 9, right? Because positive 3 or negative 3 squared is 9. X squared, second powers make things come out the same, don't they? Second powers make things come out the same. So it makes sense if it's on the same side of a vertical asymptote, both down or both up, it's going to be second power. Or if it's on opposite sides, one up, one down, That's first power. That's for x-intercepts and for vertical asymptotes. Same thing. Okay, so that we look here. So let's look at the vertical asymptote -3. It's going up on one side of it, down on the other side of it. So that one's going to be a first power. First power. This x-intercept was first power too. And then what about the vertical asymptote at 4? It's going up on this side of it and up on that side of it. This one's a second power, isn't it? It's going up on both sides of that vertical asymptote. This guy's second power, the 4, is second power. Right? Do you see that? Because again, second power, what does a second power do? It means if you go to either side, you plug in 3 or -3. Either way, it's the same thing. It's up on both. That's what's happening here. It's going up on both sides of that vertical line. Does that make sense? If you want more explanation, it's x minus 4 squared, because if you're to the right of it, you're like 5. That comes out +1. Over at 5, it's up. Or if you're at 3, you're over here to the left of it. 3 minus 4 squared is the same thing. It's +1. It's also up. See, that's why it's squared. Whereas on this one, if you're one side of it, you're up. Your other side of it, you're down. That's not second power. That's first power. Okay. Probably beat that drum enough. Okay, so we have our basic equation. Let me write it out. We have y equals, the top is going to be k x minus 2 to the first power. The bottom is x minus, watch here, minus a -3 plus 3, right? Double negative. There's the minus right from the formula. They're all x minus at first. X minus at first. X minus at first. But if it's x minus -3, you know that's +3. And this is x minus 4, and it is squared. Because that vertical asymptote, it's up on both sides. Okay, so now we got to find the k. How do you find? So that's step number 1. Step 2, find k by plugging in the y-intercept. What's the y-intercept? It is, let me change my color up here, right there, where the graph hits the y-axis. Whereas this is the x-axis, this one's an x-intercept. Anyway, that's the point 0, -2 right there, isn't it? 0, -2. So plug in the x, plug in the y. So plug in the y right there, -2, and plug in the x to all those spots. What are you going to get? -2 equals.
I'm all finished. You have a good day, Mr. Harry.
Plug in x is 0 minus 2 over 0 plus 3, 0 minus 4 squared. So I plugged in that x there, there, and there. All 3 spots. And what do we get then? We get k times -2 over 3 times -4 squared. So this is going to be -2, k times -2 over 3 times 16, right? -4 squared is 16. So that's -2 is k times -2 over 48. And then 2 goes into 48 24 times. So -2 is k. I'll just put the negative on the bottom. Hey, let's just get rid of the negative right now. Just multiply both sides by -1. Gonzo. Positive, positive, right? Finally, so this is positive 24, positive 2. How do you solve for k? Multiply both sides by 24. Boom. K equals 48. There it is. So k is 48. So then bring that back up here. So the overall formula is y equals k, 48 times x minus 2 on the top over x plus 3, x minus 4 squared. There it is. That must be the force. It's amazing that we can take a really complex graph like this that snakes through the middle with an x-intercept and a y-intercept and a couple of vertical asymptote lines and up on both sides, up here, down there, and come up with an equation from what we've learned. We've got powerful techniques now for figuring out the equation from a graph. You can look at a graph and figure out the equation, knowing x-intercepts go on the top, vertical asymptotes on the bottom. If anything bounces or goes up the same side, both up, both down on a vertical, that's a second power. And then use the y-intercept to find the k. So that is excellent.